Okay, so now we're going to do inequalities in context. This is mostly just through graphing again on your on Desmos or in Delta Math, whatever it makes you do. So Gallus is opening a small bakery. She needs to figure out how many muffins and cupcakes to bake. Both types of baked goods are baked in the same type of tin. Let M represent the number of muffins and C represent the number of cupcakes. Mrs. Gallus only has 5 baking tins which can hold 12 items each, muffins or cupcakes. So the total number of muffins and cupcakes cannot be more than 60. So write an inequality to represent this idea. So that means the number of muffins plus the number of cupcakes cannot be more than 60, so it has to be less than or equal to 60. And a possible number for the number of muffins and cupcakes, there's lots of things here. You could have 10 muffins and 40 cupcakes. That would be 50 total. That's less than or equal to 60. So there's, infinitely many here. You'll graph down at the bottom with one of your colors or something here to understand what's in the possible solutions below on the coordinate plane. Basically, what you want to do is take this and kind of turn it into a linear equation. Hang on a second. And they use M as the x-axis. So we should solve for C, to make C kind of our y-axis. So essentially we're going to subtract M from both sides. So it's going to be C is less than or equal to negative M plus 60. And the idea is you have a negative slope. You just draw this like a line. And 60 would be our y-intercept. And you'd have a slope of negative 1, and that would go down to as going to end up being also 60 down here. And we got to be less than, so you're shading in everything to this side. And the reason why it goes down to 60 on the x-axis too is because if I have a slope of negative 1, I'm going to down 1 over 1 every time. I went down a unit of 60 and over 1 a unit of 60. Okay. Mrs. Gallus knows that she will need at least 20 muffins. So that means M has got to be greater than or equal to 20. Give one possible solution for the number of muffins she could make. Well, she's still got to be less than 60 total, but she needs more than 20. She could make 30 muffins and 10 cupcakes. That means she has more than 20 muffins, but she has less than 60 total. Again, there's almost infinitely many solutions here. So now we graph this, but that one's kind of easy. So our muffins was along here, cupcakes along here. So M must be greater than or equal to 20. You just go to 20, draw a line straight up and down, and it's got to be greater, so it's got to be this side. Ms. Gallus knows that she sells at least as many cupcakes as muffins. So write an inequality to represent this idea. So she's got to have at least as many cupcakes as muffins. So C has to be greater than or equal to M. Give one possible solution. Well, again, she needs greater than 20 muffins for this and 50 cupcakes. Now that's going to be more than our 60 before, but still satisfies this one. So we graph this. C is greater than M. And that's just a good old-fashioned x equals y. So you'd have a graph that starts here and just goes straight up like that. And C's got to be greater than M, so it'd shade up there. We'll see all that on the graph here in just a second. Give a possible number of muffins and cupcakes that works with all these things Mrs. Gallus knows. Show how it works with the 3 rules. So I picked, here's the first graph when we said from 60 down to 60. Then we go to 20 and greater, and then we go C has to be greater than M, greater than or equal to. Now remember, we'd have these dotted lines if they didn't have equal to. They all have equal to. So I picked 25 muffins and 30 cupcakes. That satisfies all 3, because 25 plus 30 is less than or equal to 60, 25 is greater than 20, and 30 is greater than 25. So that satisfied all the stuff we need. So is 30 comma 20 a solution? So we go over to 30 and up to 20, and no, it's not. That does not satisfy the C is greater than M. 30 greater than 20 means more muffins than cupcakes, which it has to be the other way around. Is 20/20 a solution? That'd be right there. Yes, it satisfies all three inequalities. So to find three systems, you're just looking for anything in the overlap. It's got to be somewhere in here. So this is a solution, this is a solution, this is a solution, this is a solution, this is all of these. There's actually not infinitely many because we have a discrete thing. You can't have part of a cupcake or a muffin. But any one of those points would actually work. So we could have 25 and 30. That would actually work like up here. So we said it did. They're all in the common shaded area. So that's all it is to this. All you're going to do is shade, graph the lines, shade them appropriately, and find something that falls into the common shaded area. And that is it. Good luck.